Hello everyone and welcome to the study guide session of lesson 4-4, scientific notation, and you can find this on page 79. As always, we're going to scan the lesson and see if we can list two real-world scenarios in which we would use scientific notation. So remember when we learned about space, in determining large numbers, we would use scientific notation. So for example, determining the distance between planets. Jupiter is extremely far, so is Pluto and Uranus. So those are extremely large numbers when measuring them in kilometers, so we would use scientific notation to write down the distance. But it also works with very small numbers, such as describing the size of a cell, and when we know that it's going to be a very, very tiny fraction of a centimeter. Okay, so this is for scientific notation. Here on the side we have a vocabulary. How can the English definition of standard help you remember how standard form is used in mathematics? Well, the English definition of standard means normal. Okay, normal, average. So if we write the word normal, then I think, for me at least, that helps me remember that it's just a normal number. A standard form is just writing the regular normal number, 1, 2, 3, 4, 5, you know? Okay, let's make that one of the key answers. Please circle it. Let's do the real world link now. Earth is the third planet from the Sun in our solar system. Because Earth's rotation about the Sun is not circular, the maximum distance between Earth and the Sun is about 95 million miles, and the minimum distance is about 91 million miles. Write 91 million using numbers. So we're going to write 91 millions using all the zeros. Remember, there's 6 zeros in a million. So it looks like this. Okay? What is the value of 9.1 times 10? 9.1 times 100. Okay? So 9.1 times 10, this 10 is going to move the decimal place over once. These two zeros right here is going to move it over twice. So 9.1 times 10 becomes 91, and 9.1 times 100 becomes 910. Remember, it moved it over two places. It went from here, 1, 2. Okay, so we have the first two steps for the table. Now let's see if we can continue the pattern, right? Now 9.1 times 1,000, 1, 2, 3. So remember, the decimal places moves. The decimal moves. The number of places is 0. So here it's going to move 1, 2, 3, and we get 9,100. Okay, now we have to continue the pattern here by adding a 0. Here we went from 1,000. Let's write 10,000, 100,000, 1 million, and 10 million. Go ahead and do that. There we have it. And now that you've added a 0 to each one of the powers of 10 right here, don't forget that because you've added a 0, the decimal place will move over 1 extra time. Over here you had it moved 1, 2, 3 because you had 3 zeros. Now here 1, 2, 3, 4, so it's going to move over 4 times. So you get 91,000, right? We went from here 1, 2, 3, 4, right? Okay, continue the pattern, please. You can pause the video now and try these on your own. 5 zeros, it moved over 5 times. 6 zeros, it'll move over 6 times, and it'll give you 9,100,000. Okay, now we have 1, 2, 3, 4, 5, 6, 7. Now we're going to move it over 7 times, and we get the number 91 million. So this is how we write in the numbers. This is a standard notation. And over here, this is not quite scientific yet, because in order to turn this into scientific notation, we have to use exponents instead of zeros. Number 4. Multiplying 9.1 by what number results in the original number? Well, the original number was 91 million miles, right? 91 million miles. Here's 91 million. What do we have to multiply it by? So we have to multiply it by 10 million. And what is that number written as a power of 10? What is 10 million written as a power of 10? Well, we just have to count the zeros, boys and girls. 1, 2, 3, 4, 5, 6, 7. So we write it as 10 to the power of 7, right? And now let's put it all together. Let's make a scientific number. how could you rewrite 91 million as the product of a number, so a number like 90.1, and a power of 10? Well, let's put these two together. We take 9.1 and 10 to the power of 7. There you have it. 9.1 times 10 to the power of 7, and we've put it all together now so that it'll give us a product of 91 million. And that's how we write scientific notation. Let's try it one more time. Based on your answer to number 6, what is 95 million written as the product of a number and the power of 10? So 95 million, the only thing that's going to change, boys and girls, is now it's no longer 9.1, so now it's going to be 9.5. And there you have it. Okay, I think we're due for another key answer. Here's an interesting fact. It takes sunlight an average of 8 minutes and 20 seconds to travel from the sun to the earth. Please write this down as a key answer. If I see this written down in your notebook, I know that you've watched this video. Now, why do you think they say an average? Well, they say an average because, as we just learned, sometimes the earth is 91 million miles away from the sun, and other times it's 95 million miles away from the sun. So this is an average of those two. Let's pause the video so that you can copy this down. Pause now. Okay, on the next page, we're going to practice picking out scientific notations. See if it's easy for us to understand what a scientific notation looks like. Okay, let's see. Circle each number below that is written in scientific notation. And keep in mind that scientific notation is written as the product of a number and the power of 10. So do we have the product of a number times the power of 10 right here? It looks like we do, but actually, here's a small mistake. This number cannot be in the 10th place. It must be in the 1. Okay? So, this cannot be it. But here, let's see. Do we have a number in the 1's place? And then base 10? Yes, this would work. If we multiply this, we would have to move the decimal over 12 times. So, go ahead and circle this one. Alright? At this point, boys and girls, knowing how to pick them out, now that you already know how to pick them out, please pause the video and try the rest on your own, and then click play again to see your answers. I'm going to continue on, but please, for your own sake and your own benefit, pause now and then check your answers. Okay, I hope you paused the video. I'm going to continue on. I have product of a number. Let's see, it's number. So I have a number in base 10, and yeah, this is going to tell me that I'm going to move to the left 22 times. So this is going to be a very small number, but yes, this is scientific notation. Okay, again, I have a number in the 1's place, and I'm going to move to the left in that direction 7 times. So yes, this is scientific notation. Okay, here, no, this should be 1.06 instead of it's 10, so no. And here we don't have a number in the 1's place as well, no. Here, yeah, this looks right. We have a number in the 1's place, and we're going to move it over 9 to the right. The decimal, we're going to move 9 to the right. Yeah, that looks like it's a correct form of scientific notation. As well as here, a number, we have a number and a base 10, so yes. And again, let's see, finally, what do we have here? Well, we don't have to put the 0, okay? We would just put the 6. You don't have to put the decimal 0. If it's a 0, you don't write it. So no, this is not that's not the correct way to write a scientific notation. So that one doesn't count. Okay, let's see what we're doing here. Now we're going to compare and order numbers written in scientific notation. Always read instruction, boys and girls. Write each number in standard form. Okay, so we're going to write each one of these numbers in standard form. Then order each set of numbers from least to greatest. And let's put them from least to greatest right there on the line. Alright, let's find which one is the least. So I say let's change them all to standard form first. Okay, we can do it just above here or just below, and then maybe on this line right here we can put the actual answer. Okay, we'll use this line for practice and this one for the actual answer. The practice, what I mean is we'll just convert each one of these numbers into standard notation. So we have 4.05 times 10 to the 5th power. Remember, this 5th power is going to make the decimal jump over 5 times to the right. And the next number is 420,000. That's already written in standard form, so we can just copy that. 3 times 10 to the 5th power. Again, the decimal is going to move over 5 times, so we need 5 zeros. And we get 300,000. And then finally 1.3 times 10 to the 5th power. Again, it's going to move over 5. Let's go ahead and write that. And after moving the decimal place over 5 times, it becomes 130,000. Okay, now we have to order each set of numbers from least to greatest. And like I said, I want to do that right there. Least to greatest. Here's our least number, 130,000, 300,000, 420,000. Oh no, skip that, 405,000, and then 420,000. There we have it. So it would go, now that you already have this copied, you can actually move it around. We have 130,000, 300,000, 405,000, 420,000. But rather than writing it like this, boys and girls, please copy them in the standard, in the scientific notation, or as they have them written up here. So we have 1.3 times 10 to the 5th power, 3 times 10 to the 5th power, 4.05 times 10 to the 5th power, and 420,000. As a key answer, I want you to write the scientific notation under it. So I know that this was not expected, but I want you to write this, add it just below this number to show that you watched this part of the video. So 4.2 times 10 to the 5th power is how you write 420,000 in scientific notation. Now that we practiced doing number 1, I think you can do number 2 all on your own. So please go ahead and do number 2 as we did it, where you just convert them all to standard notation right here, okay, to standard notation, and then right here where the arrow is, you put them in order from least to greatest. Okay, go ahead and do that. I won't do it for you. I just want to see that you are going to make the attempt to do it on your own, and I will see it and check it in class. Number 3, how do you compare numbers in scientific notation? First, compare the exponents. If the exponents are the same, then compare the factors. We compare the exponents, and if they are the same, like if it's 10 to the power of 3, obviously 10 to the power of 3 will be smaller than 10 to the power of 5. If the exponents are the same as we had before, where we had a lot of 10 to the power of 5 in the first question, then we compare the factors. Then you compare the base, compare the number to see which was smaller or greater. And finally, you write the lesson summary. Here you're going to write 2 to 3 sentences to summarize the lesson. Remember that you always get clues from the side here. We learned how to write numbers in scientific notation, right? So you can write that there. And we also worked on comparing them in order, putting them in order, correct? All right, boys and girls, that's it for today. I'll see you in class.